spend a lot of time solving one-step, multi-step equations. Now we're going to actually move on to solving equations with the variable on each side, meaning on each side of the equation. So there's going to be a variable to the left of the equal sign and a variable to the right of the equal sign. That's what that's meaning. Okay? So sometimes the variable will appear on each side of an equation. I would write this down because we're going to be using these steps. To solve these equations, use the addition or subtraction property of equality to write an equivalent equation with the variable terms on one side and the numbers without variables or constants on the other side. So, let me kind of explain what that means. Yes. 91. If you want to follow along, it's on page 91. So what this paragraph is saying is it wants you to rewrite your equation as an equivalent equation, and it wants all your variables on the same side of the equation, and then it wants all your constants, your numbers without variables, on the other side of the equation. Does that make a little more sense than what this is saying? Okay. We're just going to use our inverse operations to do that, our addition and subtraction properties of equality. So we're going to either add or subtract things to get all the variables to one side, and then get all my constants to the other side. Now, when we're doing this, I like us to do our variables first. I want to get all our variables to the same side first, and I'll explain why later. And then I want you to do your constants second. Don't do your constants first. I want you to do your variables first. Everyone say variables first.
Variables first.
Variables first. Okay. There are quite a bit of notes today, so I'm going to go ahead and move on. I'll give you a few more seconds, and I'm about to move on. Once again, we're on page 91, if you'd like to follow along in your textbook.
Do we have an assignment today?
There's a good chance. Good chance. Okay, let's go ahead and move on. Right into an example. Solve 5 plus 7a equals 4a minus 13. Check your solution. So, my goal is to get the variable isolated on one side of the equation completely by itself. Correct? Just like it said on the previous paragraph, sometimes we get a variable on each side of the equal sign. Okay? What did I say I want you to deal with first? The variable or the constant?
Variable.
The variable. I want you to deal with the variable first. Once again, I'll explain why when we get to the examples that are going to show why I want you to do that. So, I want to get my variables to the same side before I do anything else on this problem. Do you think it matters which side of the equation I get them to? No, I can get them to the left or I can get them to the right. It does not matter. Whatever I do, I've just got to get the constants to the opposite side of it. So, which side of the equation do you guys want the variable on? I usually like it to the left, but we can go to the right if you guys want.
I like the right.
You like the right? Let's do the right. I heard right. So, I want to get all my variables to the right side of the equal sign. Okay? So, that means this 7a is on the left. I need to get it over to the right. How am I going to get 7a to the right?
Swap 7a with 13.
Not quite. I can't just swap them. I've got to use mathematically sound operations. It's 5 plus 7a. It's a positive 7a.
Minus.
Yeah, so I can subtract 7a. Golly. And that'll cancel out on that left side of the equation. Right?
Yes.
Whatever I do to one side,
Yeah, do the other.
got to do to the other. Everyone okay with that concept? Still, keeping my equations equivalent by doing the same thing to both sides. The left side, what do I have left over after the 7a's cancel?
5.
5 equals, now would 7a combine with my 4a or with my negative 13?
4A.
4a. They're like terms, right? I'm going to combine it with whatever like term it has over here. Okay? So what's 4a minus 7a? Negative 3a. I cannot lose my minus 13. It is still over here on this right side of the equation for right now. Are we okay with that?
Yes.
Any questions on what I've just done?
No.
Do I have all my variables on the same side of the equation now? Yeah, they're all on the right side of my equation. Okay? After I get my variables to one side, I want to get my constants. What's a constant?
It's a term that doesn't change. Numbers without variables.
Yeah, numbers without variables are constants.
Right.
Okay? So, I want to get all my constants to the other side of the equation, away from my variable. So, what number am I moving now?
13.
13. Because it's on the same side as my variable, I need to get it on the other side. So, it's negative 3a minus 13. So, how would I cancel it out on the right? Add 13. Whatever I do to one side,
You gotta do the other.
got to do the other side of the equation as well. Are we okay with that? Okay. On the left side, what is 5 plus 13?
18.
18
20.
equals, what do I have left over on the right?
3A.
Negative 3a. Any questions on what I've done? Okay, so I've got my variables to one side. I've got my constants to the other side. Now I can try to just start isolating my variable. So what number's on the same side as a?
3.
Negative 3. What's the operation going on between negative 3 and a?
Multiplication.
Multiplication. What's the inverse of multiplication?
Division.
Division. So I'm going to divide by negative 3. Cancel it out. Do the same exact thing to the other side. 18 divided by negative 3. Negative 6. Negative 3's cancel out. I've just got a. A is now by itself on one side of the equation, so I've got my answer. Are we okay with that?
Yeah.
So, get your variables to one side of the equation. Get your constants to the other side. Isolate the variable. Okay? Any questions how I got a equals negative 6? Now, notice it tells me to check my solution. How do I check my solution?
Plug it in.
Plug it back in. Can I erase this work over here so I can check my solution?
Yeah.
Plug it into my original problem, right? So anywhere I see an A, I'm going to replace it with negative 6. So I'll get 5 plus 7 times negative 6 equals 4 times negative 6 minus 13. And now I'm just working down both sides of the equal sign. I'm not trying to use inverse operations here when I'm checking my solution. I'm just keeping everything on the left and working it out using the order of operations. Same thing on the right, using my order of operations to work it down. I'm not moving anything from one side to the other anymore to check. Okay? So on the left side, what's going to come first, addition or multiplication?
Multiplication.
Multiplication. What is 7 times negative 6?
36.
No. 42.
Negative 42. Multiplication is going to come first on the right as well. What's 4 times negative 6?
Negative 24.
Negative 24. Are you okay with my first step, checking my work? Now, 5 minus 42 is going to give me what?
37. Negative 37.
Negative 37. Negative 24 minus 13 is going to give me
11. Negative 11. A positive? No. Oh no. 37.
negative 37.
Guys.
Does negative 37 equal negative 37? Is that a true statement?
I don't know.
It is a true statement, so I know my answer checks out. If you get a true statement after you plug back in, you know your answer is true. You know you got the correct answer. Okay? Any questions on example 1 here? We okay with that concept? Okay? Word problem. The results of the 2015 Nathan's Hot Dog Eating Contest are shown. So over here on the men's side, we got Matt Stoney with 62 hot dogs eaten. That includes the bun. Mickey Sudo was the women's winner with 38 hot dogs. That's hot dogs eaten, including buns. And this is after the 10-minute mark. That's how many they ate after the 10-minute mark. Okay? Suppose the men's and women's winners, Matt and Mickey, decide to compete against each other. To make the competition more interesting, Matt will not start until Mickey has eaten 20 hot dogs. Assume that Matt and Mickey eat at a constant rate throughout the competition based on the number of hot dogs eaten in 10 minutes, which is up here. These are the number after 10 minutes. By Matt and Mickey, how many minutes after Matt starts eating will they have eaten the same number of hot dogs? There's a lot to take in here. A lot of information. Okay? So, what's the unknown here? What are we trying to find? Yeah, how many minutes after Matt starts eating will they have eaten the same number of hot dogs? Right? I believe the book uses the variable m to represent that number of minutes. Correct me if I'm wrong. Someone who has their book open. M is going to equal the number of minutes after Matt starts eating that they will have eaten the same number of hot dogs. Okay? These two numbers right here, 62 and 38, are the number of hot dogs they've eaten after 10 minutes. So let's break that down into number of hot dogs per 1 minute. Right? So, I could do 62 divided by 10. Can anyone tell me what 62 divided by 10 is? Because I'm doing the number of hot dogs they ate in 10 minutes divided by the 10 minutes.
It's 12 something.
It's not 12.
Oh, 6.
You got a calculator right there. 62 divided by 10.
Sorry, not too good.
6.2.
6.2.
So Matt's eating 6.2 hot dogs per minute. That's what that means. Okay? So, how many hot dogs is Mickey eating per minute?
3.8.
3.8. 38 divided by 10. 3.8 hot dogs per minute. Okay? So, 6.2 times the number of minutes is going to give me Matt's total number of hot dogs eaten, right? 3.8 times the number of minutes is going to give me how many Mickey has eaten.
Right.
But, what's Mickey's advantage here?
She ate 20 hot dogs before he started.
She's going to get a 20 hot dog head start, right? So what can I add to Mickey's 3.8 M? Not 2.
Oh.
20, right?
Yeah.
So the total number of hot dogs that Matt eats equals the total number of hot dogs Mickey eats plus 20 because she's got that 20 hot dog advantage. Okay? This is going to give me, this is my equation that I'm going to use to give me the number of minutes, how many minutes after Matt starts eating will they have eaten the same number of hot dogs. Okay? So there's my equation. 6.2 M equals 3.8 M plus 20. So, I'm now going to solve this equation for M. So, what would be my first step here if I've got variables on both sides of the equal sign?
Minus 20. Minus 20.
Now, minus 20.
Minus 3.8.
Yeah, remember, I want to get my variables to the same side of the equal sign first. So I'm going to subtract 3.8 because it's a positive 3.8 M from both sides of the equal sign. Now, what is 6.2 minus 3.8?
I'd say like 10 per chance. But that's wrong.
1.6.
Not 1.6. You guys have calculators, right?
No.
6.2 minus 3.8. What? 2.4. M equals this 20 over here. Are all my variables on the same side of the equation? Yeah, they're all on one side of the equation. Are all my constants on the other side of the equation?
Yeah.
Yep. So now I can start trying to isolate my variable of M. How would I get M by itself? Divide by 2.4 on both sides. Someone with a calculator. 20 divided by 2.4 gives me what?
8.3.
Huh?
8.33333333.
8.33
Okay, you can stop.
minutes, right? Just round to the nearest hundredth. 8.33 as a fraction would be 1/3. So 8 1/3 minutes. So after 8 1/3 minutes, they will have eaten the same number of hot dogs if Mickey gets a 20 hot dog head start.
Mickey's slow.
Any questions on example 2? You okay with that?
Sorry.
Okay. You might want to write these steps down. I'll give you quite a bit of time on this slide. I'll give you quite a bit of time. Some equations contain grouping symbols. We've dealt with grouping symbols before, correct?
Yep.
Parentheses, brackets, stuff like that. Grouping symbols can include parentheses, brackets, and fraction bars. The steps for solving an equation can be summarized as follows. I want you to write these steps down. Everyone is writing these steps down right now on their notes. Everybody. Step 1. Simplify the expressions on each side. Remove any grouping symbols. Use the distributive property as needed. So our equations are going to get a little more complex here as we go. So the very first thing you need to do, step 1. Simplify both sides of your equal signs. Combine any like terms you have. Use distributive property to get rid of any parentheses. Stuff like that. Get it all condensed down as far as you can get it on each side of the equation. That's what step 1 is saying. Step 2, after we've simplified both of our sides of the equation, we're going to use the addition and or subtraction properties of equality to get the variable terms on one side of the equation and the constant terms on the other side and simplify. So that's what we've been doing the past 2 examples. Got the variables to one side and my constants to the other side. Step 3, use the multiplication and division properties of equality to solve, to isolate your variable. So we really just added one step here to what we've been doing on the past 2 examples. Now we're going to just have to simplify before we start moving our variables and our constants. Okay? Any questions about those steps? I'm going to give you a little bit of time to write these down. Okay, let's go ahead and move on. Okay, example 3. Solve 7 times the quantity of n minus 1 equals negative 2 times the quantity of 3 plus n. So we got some grouping symbols here now. So on the previous slide, what did step 1 tell us to do? Simplify what?
The expression on each side.
Yeah, I want to simplify both sides of my equal sign if I'm able to. I don't want any grouping symbols. So I want to get rid of my grouping symbols, okay? Use the distributive property as needed. So I've got grouping symbols on both sides here.
Can you be in the
Shh. How am I going to get rid of my grouping symbols here?
distributive property?
Yeah, use distributive property as needed. I can't simplify anything inside my grouping symbols, but I've got things being multiplied by my grouping symbols. I've got something being multiplied by a parentheses. I can use the distributive property, distribute that number through the parentheses. So the left side of the equation, what's 7 times n?
7n.
7n. 7 times negative 1 gives me what? Negative 7. Is there any questions or confusion how I've simplified my left-hand side of the equation so far? Okay, same thing on the right. I've got distributive property. Negative 2 times 3. Negative 6. Negative 2 times n.
Negative 2n.
Negative 2n. Are we okay with the distributive property? Okay, on the left-hand side, can I simplify anything else? Do I have any other grouping symbols?
No.
No. Do I have any like terms here?
No.
No. What about on the right side? Any grouping symbols? No. Any like terms? No. I cannot do anything else to simplify either side, can I? So now, step 1 is complete. I've simplified the expressions on each side. Now I'm moving to step 2. I want to get my variable terms on one side of the equation, and then I want to get my constant terms on the other side. So, raise your hand if you can tell me how I'm going to do that here. What's the first thing I'm going to do? Try it. Try it. Take a shot.
Subtract. 2 in.
I subtract 2 in. I got negative 6 minus 2 in. What's the inverse of subtraction? Addition. So I can add 2 in to cancel it out on this right-hand side.
Oh, yeah.
Whatever I do to one side,
Gotta
got to
do the other.
do to the other.
Other side.
We okay with that?
Yes, sir.
This is me getting all my variables to the left side of the equation. Do I have to move them to the left?
No.
No, I can move them to the right. If I wanted to, I could have subtracted 7 into both sides as well. Is 2 in going to combine with 7 in or negative 7?
Negative.
7 in.
7 in, right? These are like terms with each other. So what's 7 in plus 2 in?
9 in.
9 in. Don't forget about the minus 7. It is still over here for right now. What's left on the right-hand side?
Negative 6.
Negative 6. Are we okay with that first step of getting the variable, or the second step of getting the variables to the same side?
Yes, sir.
Okay. I got my variables to one side. Now what do I need to do?
Add the negative.
Plus 7.
Plus 7.
Add 7. What is 7? What do we call that? If it's a number without a variable.
Constant.
Constant. I got my variables to one side. Now I need to get my constants to the other side of the equation. I'm going to do that by adding 7 to both sides here. So on the left side, I've got 9 in. And on the right side, what's negative 6 plus 7?
1.
1. We okay there?
Yes, sir.
So all the variables are one side, all the constants are on the other. Step 2 is now done. Now I'm going to do step 3, use multiplication and division properties of equality to solve to get my variable by itself. So how would I get in by itself here?
Divide by 9.
Divide by 9, because it's being multiplied by 9. Does 1 divided by 9 give me a whole number?
No.
Nope. It's a fraction. Can I simplify this fraction at all?
No.
Nope. So I'm just going to leave it as 1 over 9. And there's my answer. Any questions how I got that?
No.
Follow these steps when you're solving your problems. Okay? And it should help you, hopefully. I would assume it would. Just follow them step by step. And you'll get your answer. Okay? Questions on example 3? Yep.
How long is the class?
Say it again.
How many slides are left?
A few. All right. Example 4. Solve an equation with a fraction bar. Solve 5y equals the quantity of 12y plus 16 divided by 4. So we've dealt with fractions a little bit in the past. If a whole side of my equation is written as a fraction, what have we been doing in our notes and our assignments? What have we been doing to handle our fractions when they're written like this?
Top over bottom?
Say it again.
Top over bottom? Or down?
Not quite. That's going to be doing too much work in this situation. Okay? 12y plus 16 is being divided by 4. What's the inverse of division?
Multiplication.
Multiplication. So if I multiply by 4, that's going to cancel out that denominator. Okay? Whatever I do to one side,
Yeah, do the other.
got to do to the other. So on the left, what's 4 times 5y?
20y.
20y. And on the right side, what am I left with after I cancel the denominator out? 12y plus 16. It just leaves my numerator after the denominator cancels out with that 4. It makes my problem a lot nicer to deal with. Okay? Okay. So I've gotten rid of that fraction, got rid of the fraction bar. What would I do next? Or what would you guys do next in this case?
Subtract 12 over 20. Or
Say it again.
20 minus 12.
Yeah. I'm going to get my variables to one side of the equation now. Because can I do any more simplifying over here on the left?
No.
No? Can I do any more simplifying on the right?
No.
No. So now I'm going to start getting my variables to the same side. So we're going to subtract 12y. Whatever I do to one side, got to do to the other. 20y minus 12y gives me 8y. What's left on the right side? 16. Do I need to do anything else to get my constants to the other side? No, they're already there for me. I didn't have any constants over here. They were all already over here for me. Okay? Now, got the variables on one side, constants on the other. Now I can focus on getting the variable by itself. How do I get y by itself? Divide by 8. Left, I've got y equals what's 16 divided by 8? 2. The variable is now by itself. Y equals 2. Are there any questions on example 4 here? How are we feeling so far about equations with variables on each side? Good, good, okay. Can I move on? Example 5. Oh, we got some geometry involved now. Get y'all a little prepared for geometry next year. It's good stuff. You having fun yet? Find the value of x so that the figures have the same area. Area of figures. You guys know how to find area of certain figures?
Sure.
You do? Anyone? Does anyone know how to find the area of like a rectangle or the area of a triangle?
I used to.
It's like,
Back in my old days.
Huh? What'd you say? Say that again, please. Go ahead and say it again, please. You said times both sides? Yeah. So for a rectangle, the area is length times width. Area of a rectangle, did you say that? Sorry, I didn't hear you. Area of a rectangle is length times width. Anyone know the area of a triangle?
use it. Like times width and then like divided by 2 or something.
1/2 times base times height. Okay. So now you know the area formulas for each of these. I would write these down in my notes because you're going to have a problem similar to this on at least a future assignment. So you need to have it in your notes so you know the area formula for a rectangle and a square. So, how would I find the area of this rectangle?
5. Wait, do we have to like add the x plus 4 first? Or?
Well, do I know what x is?
No.
No.
Oh.
So I can't add them, right?
Yeah, okay.
So 5 times
X plus 4.
x plus 4. Length times width, right? Or width times length, same thing. So there's my area expression for this rectangle. What would the expression be for this triangle? 1/2
1/2
Times 12.
times 12, because that's my base of my triangle. What's the height of the triangle? Times 2x minus 6. There's the area expression for my triangle. So let's think about what it's wanting here. It says find the value of x so that the figures have the same area. So here's the area of my rectangle. Here's the area of my triangle. If I want them to be the same, what am I going to do with these two expressions? What mathematical symbol do we use to make things the same? Equals, right? So I'm going to do 5 times x plus 4 equals 1/2 times 12 times 2x minus 6. We okay with that? And now I'm just solving for x. And that'll give me the value of x so that the figures have the same area. So, I've got variables on both sides of the equations. I've got grouping symbols. I'm going to be following those steps that we wrote down earlier. So step 1, what am I doing? Simplifying both sides, both expressions, right? On each side of the equation. So what can I do here on the left?
Distribute.
Distribute. 5 times x 5x. 5 times 4.
20.
20. We okay with that? Before I distribute here on the right, I can go ahead and do 1/2 times 12. What's half of 12?
6.
6. We okay with that? Can I simplify the left-hand side anymore?
No.
No. Can I simplify the right anymore?
Yeah.
Yeah, what can I do now over here? Distribute. So I'm going to bring my left side down, 5x plus 20. What's 6 times 2x?
12.
12x. 6 times negative 6?
Negative 36.
Negative 36. Are we okay with that? Can I simplify the left side anymore? No. Can I simplify the right side anymore? No. So I've simplified both sides of my equation as much as I can get them simplified. Now I can start getting my variables to the same side, constants to the other side. So raise your hand if you can tell me what we want to do next. Cash.
Is 5. Wait, no. 1. Wait, I don't know.
12 minus 5?
Yeah, I just want to get my variables to the same side of the equation, right? Once again, it does not matter which side of the equation we get them to. Sean, sounds like you want to get them to the right. We can get our variables to the right side. So I'm going to subtract 5x from the left to cancel it out. Whatever I do to one side, I got to do to the other. So on the left side, I'm left with
20.
20 equals, what's 12x minus 5x? 7x. And I still have that minus 36 on the right for now. You okay there?
Yes, sir.
Are all my variables on the same side now? Yep. Now I need to get my constants to the other side, right? So how do I do that? Add 36 to both sides. 20 plus 36 gives me 56 equals 7x. Variables are on one side, constants are on the other. Now I can isolate the variable. How do I get x by itself? Divide by 7. 56 divided by 7 gives me 8. X equals 8. So the value of x, so that the figures have the same area, is x equals 8. If I were to plug in 8 here and 8 here and calculate the areas, I would then have the same areas for each figure. You will have an example like that on some problem, whether it be today or in the future. You will have at least one problem like this. So be prepared. Okay? Questions on example 5? So, let's talk about this real quick. Identities and equations with no solutions. An equation has one solution if exactly one value of the variable makes the equation true. So if only one number can be plugged in and make the equation true, I've only got one solution. An equation has no solution if there's no value of the variable that makes the equation true. If there's no number that makes it true, then obviously there's no solution. An identity is an equation that is true for all values of its variables. So an identity, I can plug any number in that I want to, and I'll always get a true statement out of it. Okay? These types of solutions are why I want you guys to always deal with the variables first, and I'm about to show you why. Okay? So, I don't want to spend too much time on this chart. It's in the textbook if you want it. Let's look at this example real quick. Okay? I've got 2 more examples and I'm done.
That's crazy.
That's crazy, yeah. So, what would we do first here on example 6? Distributive property on both sides of the equal sign, right? What's 6 times y?
6y.
6y. 6 times negative 5.
Negative 30.
Negative 30. 2 times 10.
20.
20. 2 times 3y.
6y.
6y. Are we okay simplifying both sides of the equation using the distributive property? Can I simplify anything else on the left?
No.
Nope. Can I simplify anything else on the right?
No.
No. So now what can I start doing? What? Yeah, getting my variables to the same side. How do I do that in this case?
Minus
Subtract 6y. Let's try to move them to the left over here.
0.
What happens here? What do you guys notice?
0 y. Or
0y, which is just,
y.
hold on.
It's 0.
0, right?
Y would be 1.
So, in other words, my variables have canceled themselves completely out on both sides of the equation. Do I have any more y's? No, my y's are gone. So on the left-hand side, what am I left with?
Zero.
Negative 30, because my y's canceled out. On the right side, what am I left with? 20. This is why I want you guys to always deal with the variable first instead of your constants. Sometimes, when we're solving an equation, our variables cancel each other completely out. Negative 30 equals 20. Is that true or false?
False.
False. Negative 30 does not equal 20, does it? So, if your variables cancel each other completely out, and I get a false statement, my answer is no solution. You can either write out no solution, or this is the symbol for no solution, a circle with a slash through it. If your variables cancel each other completely out, and you're left with a false statement, you do not have a solution. There is no number in this world that exists that I can plug in here and get a true statement out of my equation. No number will ever make this equation true. So I have no solution. Does that make sense? And this is why I want you to always deal with the variable first, to see if it cancels out. If it cancels out, I've got to compare the statement that's left over. If it's false, no solution. Are we okay with that?
Sure.
Next example, really fast. Simplifying both sides of the equal sign. I can distribute here, correct? I'm going to move fast through this problem. 5 times x. 5x. 5 times negative 1. Negative 5. Can I simplify the left anymore?
Yes.
Yeah. I got like terms. 7x plus 5x. 12x. Can I simplify the left anymore? No. Can I simplify the right anymore? No. So, after I simplify them all, both sides of the equations, what can I do? Subtract 12x. Get the variables to the same side. What happens to my variables here?
0.
They cancel out again. I have no more x's anymore, right? My x's are gone. On the left side of the equal sign, what am I left with? Negative 5. On the right side, what am I left with? Negative 5. Negative 5 equals negative 5. Is that true or false? True. Negative 5 does equal negative 5, right? So, do you think it's no solution still? No. If my variables cancel each other completely out on both sides, and I get a true statement left over, my answer is all real numbers. Any number I plug in here is going to give me a true statement no matter what. I'm always going to get a true statement no matter what number I plug in for x. So all real numbers is my solution. Okay? That was one of our identities. Okay? Any questions on example 7 here?
No, sir.
Any questions about any of the notes we've taken today at all? We good? How do we feel about it?
Good. Great.
Okay? We ready for the assignment?
Yes.
We'll get it on Monday in class.